Hi there. So this is the second video in this series where we're going to cover the second roughing pass that we need to do to perform the machining on this Batman bust. So the first thing we need to do is return to the machining tab, and we would like to create the next roughing process. And instead of going through and defining all of the settings that we did all over again, we can simply duplicate this cutting operation. So if we right click and then click on duplicate, it will generate an exact replica of the previous path. Obviously this doesn't quite serve our needs because we need to not only rotate the toolpath, but we need rotate the object, but we need to make sure that any parameter adjustments that need changing are there. But it's a good start. So to rotate this, we're going to use the turntable as an indexing tool. So the way to do this is we need to work out which axis it is that requires rotating. Now I believe it's E2 in this instance, and an easy way to check is to highlight the angle that's defined and just scroll the mouse wheel up and down and make sure that it's turning in the correct axis, which it is. So I'm going to type in 180 there to flip it around 180 degrees. So for now, we can try generating a toolpath and see where it gets us. So I'm going to do exactly that, and it'll take a minute or two to generate, but nothing serious. We've already got most of the heavy lifting done with all of the previous definitions and settings that we made. Okay, so that looks positive so far. However, there is a red mark on our node here, which is not ideal. So what we can do is we can click on simulation and we can slow this down and then watch what happens when we run the simulation. And the first problem, it's staring us right in the face. When the turntable moves, the tool intersects with the work block. This is a problem. So instead of continuing to run the simulation through, we're going to deal with it right now. So to click on machining, and then what we want to do is we want to click on links and leads, and we want to set the approach to avoid collisions. In doing this, what will happen is this will tell the robot to take a few extra movement steps to avoid any kind of intersection between the tool and the cutting block, the workpiece. So I'm now going to regenerate the toolpath and see how it looks. So we're going to go back into simulation. We've still got a red node error here. This is a bit of an issue. We can reset the node status for now, so it goes back to being white and undefined. But generally, if it creates a red node after you've simulated it, then you've still got a problem that needs addressing. If there's a red node before you've simulated it, or after you've already made a change and before you've simulated that change, then it's generally good to reset it. So nice and slow again, and we click on run, and we'll see how the robot's moving out of the way at this point. Not quite far enough though, it just clips the very tip of this. Not the end of the world, there is an easy fix to this. What we can do is we can define the safe plane. So we're going to stop that simulation, we're going to go back to machining. Now the safe level at the moment, which is what the robot deems to be okay in terms of moving the tool away from the workpiece, is currently set to 10 millimeters from the part. Including the size of the workpiece box around the finished part, 10 millimeters probably isn't enough. So I'm going to increase this to 50 millimeters. Press return, and we can see that this safe plane here, again, can be dragged in much the same way as the bottom level was dragged before. That's all right. So we're going to click on generate toolpath again. Wait for it to generate the toolpath. And once that's generated, we're going to go back to simulation. Now, because we've got this damage to the block from the top side from the previous simulation, what we're going to do is we're going to reset the simulation, and then we're going to click on simulate up to current operation, which performs a fast simulation of what happened in the previous known good simulation toolpath. I'm going to reset this node status as well, because I want us to have a completely clean slate for the operation. And I'm going to press run. Now you can see there's no intersection between the tool and the workpiece. So far our start looks good. Going to increase the speed of this a little bit, otherwise this will take a very, very long time, and no one wants to sit through a 45-minute long video. So far this is looking good though. Okay, so we have a single reported error, contact with workpiece on rapid feed. Okay, oh no, we've got 2 instances of it. Ramp angle was too high. That we can ignore because we're dealing with a soft material, so that's not a problem. So we go back to machining, and what we can do is we can set the safe distance and the feed switch level to be higher, because we're having problems with the tool getting to the workpiece too fast from the rapid to the working speed. So if I set this to 30%, that's now 9mm safe distance, and I'm going to set the feed switch level to 150% just to give it that little bit of extra. I'm also under parameters here. I'm going to turn off check for plunges, because in a soft material like foam, a bit of plunge interaction isn't a major problem. So we're going to generate the toolpath again using these parameters. You'll notice how the more parameters that we're setting, the slower the toolpath generation gets. Unfortunately, this is a fact of life and something that we can't entirely avoid in this instance. I'm going to go to simulation again. I'm going to click on reset and then simulate current operation. And slow it down just to watch what the entry looks like. I know that our entry is good, but it's force of habit at this point. And we increase the movement speed, and we keep an eye out for any kind of issues that cause this node to turn red. Excellent. We now have 2 perfectly green nodes, which means that our roughing pass is perfectly defined with no problems and no unexpected tool and workpiece interactions. In the next video, we're going to define the finishing pass, which is a little bit more complicated. It's going to be using a full 5-axis interpolation method, which makes use of the full range of the robot and functionally is very similar to a 5-axis milling process using one of the more expensive 5-axis milling machines. Shall see you then.